Welcome to the Petrel training. This is the first video of the series. In this video, we're gonna teach you how to set up a new project in the Petrel and a little bit about the user interface of the Petrel. So here you will see the different tabs. First tab is a file. The file tab contains all the settings and save project button. Then you will see the home tab. In the home tab you will see there is a perspective. The perspective, when you select, there are different perspectives like seismic to simulation, geology and geophysics, advanced geophysics, reservoir and production, shale and data management. But currently we will work with the geology and geophysics perspective. So select that. It will give you a systematic arrangement of all the tabs and buttons which are related to the G&G. So let's see what's in the stratigraphic tab. You can see here are the options how to create the new well, the well filter, well data manager, cross section editor, new well section window, stratigraphic window, how to create the new charts, stratigraphic charts, log calculators, well top manager and surfaces making. All these are in the stratigraphic tab. The next is a seismic interpretation. It will contain the interpretation workflow, like it will begin from well to seismic tie, the wavelet tool, the log conditioning, then seismic interpretation, the volume attributes, different mixtures, and we have the geobody interpretation, the structure tools, and make surface tool and polygon editor. Then there are exploration geology tab. This is for the basin modeling, the 1D model, 2D model and 3D model, like burial history curve and here we have decision support. Then the structure modeling, where you can do the fault scene analysis, the fault framework and different structural modeling. Then we have a property modeling tab where we can use all in this tab all the tools which can help us in the fishes modeling, petrophysical modeling, and neural networks, and this that. The fracture modeling, all the tools related to the fracture modeling. Then we have a production tab and well design tab. So let's start our lesson of the day, how to create or set up a new project in the Petrel. Now go to the file and select new project. So it's creating new project. We have to wait for a while. You can see there is a looking create a new project. So wait, and here we go. There is our new project. It's empty. You can see all the tabs and the buttons are active now. So here is the input tab. All the data we will use in the project will remain in this tab, the input pane. So there's the templates, all the things we used have a template like velocity template, average velocity, everything available in the template folder. There were different tabs there like layout, messages and everything present there. So first we have to define the project coordinate reference system to locate our data on the map. So for that we have to go to the project setup, then we have to go to the project setting, and here we go, settings open. There we have option coordinates and unit. Currently the coordinate reference system CRS is undefined. We have to go to the select button and we have to select our coordinate reference system. Our reference system is, let me see, is ED50 UTM31. So we can find it from the list, but it will take some time, so we will search it. So it's ED50 UTM31. So there we go, there is our reference system. It is ED50 UTM31 European 150 based UTM zone 31 north in meters. We have to select it, and then here we go. Here is all the details of the coordinate reference system. So close it and select OK. Now you can see the coordinate reference system. Now next type is a unit system. Here it's a metric customized. We will use the metric system in this project. You can customize any unit, or it's asking us to apply the coordinate system. So first we have to press apply the project coordinate reference system, then we can change any unit we want. So click this, and here we go. This is the window with all the measurements. We can select any measurement and change its units. It's very simple. So like we can see here, let me check, like pH like porosity. There are all the default unit currently in the template. We can change that, like resistivity, all the units are there. Like we can filter that out, like we should check the depth unit. So like bit depth, it's in meter. We can change it to any other, like kilometer, feet, or anything like that. Click OK and it will change, but we will not going to change that now. Okay, you can also see the storage unit X, Y, Z values are meter area, meter square, volume, meter cube, the seismic in millisecond, and the seismic velocity is meter per second. Now for the second thing, we have to set up the project reference datum. The time reference is SRD, seismic reference datum. It will be mean sea level, and mean sea level is 0. So we have to create our SRD. Click on create, give a name SRD. So Z value at SRD it will be 0, and replacement velocity will also be 0. So OK. Now select our SRD, apply, and OK. Now our project is ready to use, and now we have to save the project, give it the name, your location, and the name. Well, so this is the option label, show font 20, click the 2D, click apply, and here you see the well names. And look, we use deltas XY for creating a temporary well, so it's present exactly on it. Look, see. So let's uncheck all the temporary wells. We can change the well colors from this option. We can set them white, click apply, go all white, and we can set as well color. Okay, here are well colors. So when we click apply, it will apply these color on the well. Okay, we can also set some values with this well in a track, like on the right we click the value as well, and let's select the value. Let's turn on the annotations, Z values, click apply. Let's increase its font so we can see it. No, still it's too small. Let's put it 300, and here we go. Let's change the side. And turn this off. Okay, there's a double value. Let me see why it's giving double value. Let's change the increment to 300. What will it see? Let's see. That's supposed to be empty. No. Let's see X values. Here we go. We can see X value. There's a problem with the empty values. So look, we can set any property or any values to display on the map in the track option. Okay, let's cancel this out. So our wells are loaded in the project. Let's delete the temporary wells. Yes, delete this too. Delete. Okay. Okay, let's remove this value. Go to the setting, again track, and uncheck, apply. Okay, so here we can see our wells. Okay, we can, let's check this out. This is a view, this is a pick mode, this is an option to measure the distance. Like click on that, like we want to check distance from alpha to pi, so we click on that. And it's not working. We have to display the well symbol for that. So go to the setting, well symbols, symbol, apply, and okay. So now click on alpha well, 2 pi, so it's give us the distance here, like there we go, is 9981.96 meter. Okay, let's uncheck that. There is a set the domain option. There's a 2 option, 3 option, any. It will show both time and depth domain. So if we want to see only depth domain, we can select TVD. It will only show us the depth data. And if we set TWT, the two-way time, it's only give us the data which is in time domain. So currently we have only wells, and wells, as we all know, is in depth domain. So when we select TWT, all data will vanish. There is nothing in this project right now which is in time domain. So let's go back to any. So as we already discussed this eye icon, click on eye and it will display all the data to the window. So this is the view from the side above. This will only activate in these all option will activate in 3D window. Let me show you that. Let's go to the 3D window. Now which side you want to see? Like I say I want to see it from the south. So when we click on the south, it will go to the south. So then again we can see from a west. This will change the direction. Again we want to see from above, click on that and it will show you from above. Okay, this is the zoom option. We can use that to zoom the data, but still we don't have any other data in this, so it will not activate. So this is another option, orthographic camera. It will show you. So let's move this, anti-roll, and now this is the important one, the Z scale. Okay, there are well, the Z scale is our depth. So if we increase that, it will increase this. See, the length of the well increase. Now it's out of our window, so we have to adjust it according to our screen. So let's just see 4. So now we can see the whole well. Okay, these are the track the cursor and track the and link the camera option. It will use during the interpretation. We will discuss about that later. Okay, the next option is the background change. Toggle the background. It can change into white or black. So when we click it, it will go to black, white. When you click back, let's go to black again. So there are options to display some elements like axis. When we click on axis, it will show us the whole axis like this. Like here we go. Like this. Okay. Now there is another option. You can set legend, compass. We already have a compass here. So now another option is a note. You can create a new note or voice note, anything. We're working and we found something, so we just click on new note, click on location, and here we can add anything, A, B, C, and click OK. So it will create a note on this location. So when we click on that, it will show us this. So let's delete the note. Okay, next, this is a copy bitmap. We want to take a screenshot of this window, so directly we can copy the bitmap, email, log, clipboard. We can so export graphic, and we can save it anywhere. We have many options like any type of PGN, PM. Okay, I hit cancel. Now this is the option. If we click this, this will remove all the data from current window. So like that, this everything is unchecked. So again we want to see all the data. We click on well main folder, it will show all the wells. Okay, let's go. Let's move forward. Now we're gonna load deviation surveys in the well. So for that we have to click the well. Like, let me see, we have deviation survey of alpha well and phi well. So first we load alpha well. So we click on GR, scam array, GR, GAPI, fine, and click OK. And let's see where are GR. There are GR. Right click, spreadsheet. Again there are no values in this, so we have to solve this problem. There is something wrong with the last file, so I have to like this, right click, and I would like first open the Excel. So I was not expecting this, but file gave error. So here is something new you can learn, how to edit a last file and solve the error. So I'm gonna open the last file into the Excel. Okay, here we go. There's the Excel, and is number 4 column. So let me delete all other. Okay, and now select, go to the data and text to column, and it's a delaminated file, it's lax, and this is space delaminated. Next and finished, and here we go. This is empty column, let's delete that. So 1 2 3 4, this is our GR, so we have to delete all the extra. Let me delete every other column, delete this. Okay, now we have empty, and this is GR. Let's put something, insert is empty, it's in feet, and this is GR. Let's save this file, save as into logs, and let's save this as a space delaminated file, delta gr log. Let's save it and save. Yes, let's close this and save, close this. So here we go, let's check the file, delta gr. Okay, let's close this, let's go there, delete the gr, to go delta, right click on that, important selection. Now we make a asci file, that's not a las file, so well log asci, and here we go, delta gr log, click OK and open. So here we go, it's a different procedure. we have to define column in this. We have to specify log to load. So 1 column, 2 column. No, the first column is defined here, and here we can see empty is decreasing, like 12,900, 12,890.5. So we have to check this empty decreasing. We have only one log. We have to define its name. Is gr is in column number 2, and its property template is gamma ray. Okay, and we already have gr global well log template, so we click that. So we go to setting, elevation is kb, auto wrap, we skip -99. We go to coordinates and units, so specify the unit. We have z value in feet. In the last file there are units are defined, so software automatically detect that and convert that to the project's unit, but in asci we have to define that manually. So it's defined and click OK, and here we go, it's loaded. Now let's check. Spreadsheet, and there we go, the gamma ray values are there. Now let's check our logs and display them. So in Petrel, to display the logs, we have to use a well cross section window. So where is the well section window? So click on that. We have to create new cross section, so we can give any name like SGS and we can create a new template or use existing template. In existing template we have a lithology, sonic, triple combo, and many other templates. So let's use a new template and click OK, and here we go, we have a well section window. Its domain is SS-DVD, subsurface DVD. So we use MD for that. You can use anyway. So you see it's an empty. So to display the well, we have to check the well. Here we go, well 1. Okay, so you can see there's no log in it. You can expand that by dragging that. You can set vertical scale from there. So let's see, 1,500, 10,000. So anyway, we can lock the scale, synchronize scrolling. What will you use in correlation? This is used for correlation, like set the well. It will give us a relative distance. We can set into constant. It will have a constant distance like 75 and relevant relative distance. Okay, now we have to put logs in this template. So for that we have to click the well. So first I want to see GR, so I click on GR, right click on that. It will go to add to a global template in the vertical and create a new track, and click this, and here you can see our GR. Okay, now well I think have no GR, that's why it's not present. So this yes, there is no GR in this well, that's why it's not displaying that. So let this display DT. Right click on that, go to global template, vertical, and we can add into GR or into new track. So click on new track, and here we go. There's a DT. This will also have a DT, so it's there. So now you can see this is a log scale, but it's a random, so we have to define a proper log scale. So for that we have to go to the template setting, and here we go, and you click on GR, and there is OS, and there you can change its template, or we want to change its scale. So here is a limit where we can see minimum, maximum, and we'll say 0 to 150 in normal direction, and click apply. So here you can see GR scales has been changed. Okay, then we go to DT, and we can define that. Go to the limit, minimum, maximum. We can see minus 40 to 140, and click apply, and here you go. You can see DT scale. Okay, you can change curve colors from there, like the line is a black line, you can use specific color from there. You can select the color, like I would say green, and click apply, so it will green. We can just set as property the color that is defined to the DT template. So as we click, there we go. We can change line thickness from there, 1 to 2 apply. We can be as thick. We can also change the line type like this, but it's usually solid, so keep it solid. And we can show our data points by clicking on that. Show in a black color, we will apply, and it will show all the data points, but we don't need this. Click apply, and okay, here you can see. So let's see our other logs. We can select row B, the density log with the DT track, and here we go. We can also send the N file if it is present in this log. Let's see. No, this will have. So let's send him to this. Okay, we can set the template from here. Click there. I will say a triple combo, and here we go. It will set a default. We will discuss about well section window and its setting and properties, and how to set the templates and everything else in the well correlation lecture. So for log loading, that's it. That's how you load and display the well logs into the Petrel. You all have to complete this task and notify us, and please save the project after all your work so you can resume from there. Thank you and goodbye. Hello everyone, welcome to Petrel training lesson number 4. Today we're gonna learn how to load well tops and seismic data. So let's start with the well tops. For that you have to right click on well top main folder, and then you have to go to import on selection. Then you have to go to the well top file, and you have to select file of type the Petrel well tops asci. Open the file. Here is an import window. First you have to delete all, delete. So let's check how many columns our file have. So it has 1, 2, 3, 4 and 5. Okay, so we have to add 1, 2, 3, 4, 5. So first is well, so click on that, select well. Then second is surface, so you have to find surface, select that. The third is MD, the surface depth or well top depth, so I have to select MD and it's in feet, so change meter into feet. Now next is time in millisecond, so let's go to the select time, get to with time picked, select that and it automatically millisecond, and then type, and we have to find type. And here we go, this type. Again, the number of header line or 1, 7. It's not changing, but I must say, oh no, okay, leave this up. You can go to definition and styles. Okay, now the next setting, this is the scale, the vertical scale. We can define that like equal to 10,000. It will show us all the well, like equal to 5, so it will give us a very good view. We can lock the vertical scale, then it will not change by this bar. So when we unlock this, then we can change this like this. You can move this. Okay, there are synchronized scrolling. If we turn this off and we select the well, so only this well will move. So if we turn this on, then it will move alongside all the other well. So this is synchronized scaling. So if I change scale this, it will change all the other wells, and then if I uncheck this and change the well, so it will change only this well. So let's lock this. Okay, we can equalize all the scale that we have disturbed. So by clicking on that, we can see all the well. Here you can see all the well. View the entire wells. Okay, now this is the horizontal scale. We can select it as a relative scale, then it will show us the relative positions of well. Here you can see that this well is closer, then this is far away, then this is again away, and these are little bit closer. Okay, now we can change the scale. So again, let me change this, and as you can see, okay, we can close it up by adding like that. Okay, now other is a constant scale. It will put all the well on the constant distance, but it will mention its original distance on this. Okay, we can increase their distance like that. Okay, then we can add comment, and we can copy this image, this window image. Okay, let's again it go to 1000 and 250. Okay, and here you can see, okay, this is quite big. So let's go to again template setting and go to well tops, go to style, label, change it to 9, click apply, and now it's okay. Click it bold, and here you can see, okay, there we go. Okay, now let's make a proper well correlation. So first let's make a stratigraphic correlation. In stratigraphic correlation, we take any horizon as a reference, and we hang all the well on that horizon. So let's see, let's suppose I want to hang all my well onto formation E. So for that I will click on the horizon, and then we'll click on flatten well section on this well top. So when we click on that, and now here you can see, let me change scale a little bit, 5000, let me zoom in, and here you can see now all my wells are flattened on this well top. So it will show us the thickness of below formation like that. Okay, we can hand on this formation, you can select on that, flat on this. So now you can see it's changed this. So this type of correlation is called as stratigraphic correlation. Usually we hang the wells on our reservoir zone, then it will show us the distribution of the reservoir species and its thickness, that how it varies from one well to another. Okay, let's suppose this is my reservoir. I will hang this hang my wells on that. Let's suppose that. So it will show you it's have almost equal thickness in chi, tau and delta well. Then again it's a little bit thicker in alpha and more thick in phi. But you see formation E is thicker in phi well but very thin in alpha well. Okay, so this is the stratigraphic correlation. Now let's move to the structural correlation. So first let's deactivate the flattening. So in structural correlation, we hang the well on a specific depth, like we hang on mean sea level. So it will show us the present structure of the area by using the well formation. So let's see. For that we have to go to the there is two other methods to flatten our well tops. The second is just go to the well top, select the well top, right click on that and click flatten on that, and then again click on that, deflat. Let's see, flat on this, and here you can see. Let's suppose flat on this, and you can see the changes. The other method is the window setting. So let's suppose our window is well section window 1. So go to well section window 1, go to its setting, and go to definition. So here we go. Here option flatten well top, click this and then click on arrow. Here the well is added, click apply, and you can see the change. So we can also change the scale from here, like I see 5000, apply, and here you can see you can change domain from there. All the other settings that are present on the top is also present in there. Okay, now there is the option flat on depth. Click on that. Now I see flat my well on TVD 0. So click apply. So here you go. Now here you can see. Let's zoom a little bit more. So here you can see our well is flatted on TVD 0. We can also change this if we want. Let's suppose 1000. So here you go, it's flattened on 1000. So this is our structural correlation. It's really simple. There are so many other settings, like horizontal spacing is 50, grid lines, page setup, this is for print, the cursor tracking, click on OK. Now we can only show limited well tops here, like if I remove this, so here you can see that you can again show them by clicking on that. So this is all about the well correlation in Petrel. So there are so many options. You have to try every option in this and play with it, then you will be used to this. And if you have any question, you can ask in our group. So that's it for today. Goodbye. Welcome to another video. Today topic is well to seismic tie. So first we have to select a line and display it. So for that we have to select the tool palette, and here you have to select seismic interpretation. I already have selected that. So there is option base map select, or short key is K. You select this and you click on the line, like I'm gonna click the line on which 5L is present, because I'm going to use the 5L for well to seismic tie. So double click on that. First you have to create a new interpretation window. Okay, then go to base map and now select. Now you can see the line is here with H, which is SGS1. So let's click on the eye icon to see the whole line. So now you see well is not shown on the section. Actually well is not selected from here. So let's select all the well. You see these options are disabled. Why? Because the seismic section is in the time domain and the well is in the depth domain. So we have to change the well to depth domain by using time depth relationship like check shot. So we can also display the well by changing domain from here. Like if we select TVD, it will show only the wells which are in depth domain, not seismic. So if we select any, it will show both, but it will not show the real image. So we have to go to again TVD or TWT. So now let's load the check shot of 5L. So click on the well, go on import on selection. Okay, now where is our data for loading? SGS and wells check shot, and there is 5, and file of type is check shot asci and open. So now we have to check our file. So we have to connect this with the well, like connect to trace and go to the well 5. So header lines are 1, 2, there's a 2 header lines only. So we have to click 2, and we have TVD in feet and 2-way time in millisecond. so we don't have MD, so delete this MD folder. Meter and millisecond. Our depth reference is mean sea level, and mean sea level is 0, SRD is 0, and we must have to select this negate time value. If our file has negative time value, then we have to uncheck this, and when our file have positive time value, so we have to check this. You can change time zone if you want, but now let's click OK. Now 5.1 CS check shot is depth domain, its range, Z range. Now click OK for all. Now in global well logs, we can see our check shot. Here our check shot, and in well fitter is 5 well. So now we have to apply the check shot to our well. So for that we have to click on the well, go to the setting, and then go to the time. We already have here, so click on that, create new and run. So it's applied the check shot on the well. So click apply, click OK, and now you can see our well is active. So click on that, and now see, here is our check shot. So well is displayed. So let's see. Let me check. I think there is some error. Let's go to setting, check the spreadsheet. Let's close this. Let's go to the check shot. Check the spreadsheet. So it's 2-way time. No. MD. Okay. I think we take MD wrong in the loading. So let's close this. Let's delete this. Let's delete this too. Yes, our well is gone. Again, we have to go to the well, import on selection, click on well, open, and here is our mistake. Our TVDS is in feet, we select meter. So here in feet, connect to well 5 and millisecond, and it's 2-way time. It's okay. So again, OK to all. OK, and now I click on that, go to setting, where it goes. Like again, I'll check it. There we go. This goes used for correlation. So like I check from cut there and check there, it's matching. This horizon match with this, and then I will use this. So let me delete this. Okay, the final thing. of this course to convert our horizon into a map. So for that, it's a very simple procedure. Let me close these. You can see here is our all the horizon values. So let's go to seismic interpretation, and there is option make surface. So click on that. Okay, first we have to go the input data. So input data is our formation E. Okay, and the boundary, it will automatically take the boundary of all our interpreted data. So if we have any polygon, we can put that, so it will limit our surface to that polygon. Okay, so the fault line or polygons, we haven't created fault polygon yet. This is the fault interpretation, the fault sticks, this cannot be used. So see, they accept only polygons, so I'm not using that. So our data is 2D line, so is seismic line low density, so click on that. Okay, now there are well adjustments, so well tops. So let me put the well top formation E. There we go. It's 2 at time. Okay, because our horizon is in time, so we'll adjust this with the time. You can adjust that, or you can only create that by using the grid. Okay, you can use in algorithms. There is convergent interpolation, conformal gridding, ISO interpolation. You can use any of this. You can Google these terms and find the algorithm behind them. So I'll click on that. Like on geometry, I'll define this is the automatic, and if we have a grid, we can get all settings from selected, or we can limit that. So grid increment 50 by 50, and let me quickly create the surface. Move up and click display after run. So let's apply. And here we go. Let me click OK. There you go. This is our surface. Let's check the surface settings. This is formation F. Let me right click on that. Let's go to the setting. Okay, let's first check the color in the local auto scale. And there we go. And click. Oh, okay. Let's again go to the setting. And let's go to styles. Let's set the contours a little bit. Like the contour interval is 25. Let's see. Let's move into 10. And apply. So okay, if I will bold, show annotations, and here you go. Okay, annotation should be bold. Okay, so let's increase it over to 30,000. Oh, it's quite good. Let's increase this to 8,000. Okay, and start from 0. And size like 1000. Okay, this is the setting. We can change that with grid line and many other calculation operations, but that are advanced level, so we are only on basic. So click OK, and here is our map. So this map shows as we move from there to there, this is our shallowness point and this is our deep. So in this direction, from northeast to southwest, we're going deeper. So let's zoom this out. Okay, so that's all for the basic training of Petrel. I hope you enjoy this and you learn something from that. Practice these things and use the data that we provided, and we'll see you in next training, the tech log training. So till then, goodbye and take care.